Imagine you're running a busy restaurant. Customers keep coming in, orders are piling up, and only one chef is cooking everything. Each dish has to wait for the previous one to finish. It doesn't matter how fast the chef is, eventually a long line forms. Now imagine hiring 10 chefs. Instead of waiting in line, multiple orders are prepared at the same time. Customers get their food faster, and the restaurant runs much more efficiently. That's the idea behind concurrency, and it's one of the biggest reasons why Go, also known as Golang, has become one of the most popular programming languages for building modern servers and cloud applications. Before we dive deeper, it's important to understand the difference between concurrency and parallelism because they're often confused. Concurrency is about handling multiple tasks efficiently. Think of it as a chef switching between several dishes, making progress on all of them without letting anything burn. Parallelism, on the other hand, is having multiple chefs cooking different dishes at the exact same time. Go was designed to excel at both. Many programming languages support concurrency, but they often rely on operating system threads. Threads are powerful, but they come with a cost. They consume a significant amount of memory, take time to create, and the operating system has to constantly manage them. As applications grow larger, managing thousands of threads becomes increasingly difficult. Go approaches this problem differently. Instead of creating traditional threads, Go uses something called Go routines. A Go routine is a lightweight function that can run independently from the rest of your program. Unlike operating system threads, Go routines require only a tiny amount of memory when they start. Because they're so lightweight, a single Go application can comfortably run tens of thousands, or even hundreds of thousands, of Go routines at the same time. But here's what makes this even more impressive. When you launch a Go routine, Go doesn't immediately create a new operating system thread. Instead, Go's runtime includes a built-in scheduler that intelligently manages all of your Go routines. It automatically distributes them across a small pool of operating system threads and takes advantage of every available CPU core. This means developers don't have to spend time manually creating, managing, or balancing threads. Go handles all of that behind the scenes, allowing programmers to focus on solving real problems instead of worrying about thread management. However, running many tasks simultaneously introduces another challenge. How do these tasks communicate safely? In many programming languages, multiple threads often access the same data. To prevent corruption, developers use locks and mutexes. While these tools are necessary, they're also a common source of bugs. Forget a single lock, and your program may experience race conditions. Lock resources in the wrong order, and your application can freeze because of a deadlock. Go encourages a completely different philosophy. Don't communicate by sharing memory. Share memory by communicating. This philosophy is implemented through channels. Think of a channel as a conveyor belt in a factory. One worker places an item onto the conveyor, and another worker picks it up on the other side. The workers never fight over the same object because the conveyor ensures everything is transferred safely and in the correct order. Channels make communication between Go routines simple, predictable, and much less error-prone. Instead of worrying about complex synchronization, developers simply send and receive data through channels. The result is cleaner code that's easier to read, easier to maintain, and much harder to break. These features are exactly why Go has become the language of choice for high-performance backend systems. Whether it's web servers handling millions of requests, cloud infrastructure managing thousands of virtual machines, networking software routing enormous amounts of traffic, or container platforms orchestrating entire data centers, Go provides the speed, scalability, and simplicity required to keep everything running smoothly. Companies choose Go not only because it's fast, but because it allows developers to build reliable concurrent systems without writing overly complicated code. So, what makes Go the king of concurrency? It's the combination of lightweight Go routines, powerful channels, and an intelligent runtime scheduler that automatically manages everything behind the scenes. Instead of fighting with threads and synchronization, developers can focus on building applications that are fast, scalable, and reliable. And that's why, when it comes to concurrent programming, Go isn't just another programming language. It's one of the best tools ever created for the job.